Thanks so much for coming. And you can be doing anything in the entire world, but you chose to come to our talks and listen to us for like 2 hours. So thanks so much. So this is going to be like sharing of what I did for some of the projects that I was working on. So some of the backstory that I have, right, is before I go in deep into it, anyone have worked with Apache Beans before? Anyone heard of it before? Apache Bean, data flow? No. So, okay. So how many of you are students, like stay studying, try to, okay. How many of you are like data scientists, machine learning, data engineer? One. Software engineer? Quite a few. Okay, so regardless, right, I will cover the basic and then we go deeper into how we works with Apache Beans to create features for machine learning system, right? So the project that I'm working on is called Fraud Finder Project. So it's try to find fraud from the credit cards transaction kind of thing, right? So there's an event when a customer purchase something, right? Then that events will generate this kind of data, which is transaction ID, transaction timestamps, customer ID, the terminal ID that you purchase with, and then there's a transaction amount, right? How much you paid for it. So what we are trying to do is, given that kind of data that we have, like every transaction, we want to train machine learning models to determine whether there is a fraud or it's the actual transaction that performed by a user itself, right? So in order to do that, right, if you're familiar with machine learning system, these are the flow that we have to take. So one, we got to collect all the data, right? So without the data, you cannot train any model at all. And before you train the model, you got to do feature engineering. So try to figure out like what's more important to learn from it, like be it how fast a particular person is spending, right? How much money you are going to spend each transaction, right? If I keep spending, let's say $20 a day, and suddenly there's like $1,000 credit transaction to your card, that likely to be a fraud, right? But there's a chance that it's not, but most likely it's going to be a fraud. So this is the typical workflow, and it's a very basic one. So, and there's a lot more to it. People will say there's a circle, right? Because you have to go back to each steps and all that. And these things here, we have data collection, we have feature engineering, we have model building, and we have model serving. So basically you want to collect all the data, train a model, right? And then you serve it to the outside world so that they can use it. But for this particular talks, we are going to just focus on the data engineering part of things. Right, so the feature engineering part of things. So before I go into the feature engineering, I want to touch base on like how the data has been transformed recently, right? So you guys know data is basically like records and like transition that's sitting on a database. It used to be low, GBs, like small. You can have MySQL database on your local server and all this thing. But it has transformed into big data recently, right? So big data is very famous right now. Everyone talking about it. So what that means is basically there's a lot of data, right? They have like petabytes of data, and each day you might even have a terabytes of data. So how are we going to like differentiate, right? And recently there's a trend of streaming data, right? The performance and all the technology is so advanced that we can now use streaming data to analyze stuff. It's not just still data. So the data is not always stationary. Sometimes it's arrived late, right? Because of network traffic, right? Because your phone has no internet, so it waits until you have the internet to send it to the server and all sort of things. The transaction happens, but due to like the network difficulty, system failure, your data might arrive late. So those are the things that, we have to figure out if we are going to work with like streaming data, right? So sometimes you don't even know whether the data is late or is there any late data coming in or not, right? There's unknown part of thing. And the requirement for me to engineer features using streaming data is for each transition, I have to create things like total number of transaction within last 15 minutes, 30 minutes, and 60 minutes. The same thing, how much amount has been transacted and average amount of the transaction for each user, right? Then we have some difficulty if we are going to work with string data. If you have the batch data, let's say in a CSV file, you know exactly when is it start and when is it end, right? You can just use a group bar statement to get everything, sum it up, right? Average it out, then you get it. But streaming data has no end or no beginning. So it's always coming in, right? You can never compute in a traditional way because the ends is not there, right? It's always futures. Some data are late and all that. And then sometimes, right, let's say some of the campaigns that our e-commerce system runs, you may have a lot of transaction coming in for within that time period, right? Let's say 1 hour promotion, 1 day promotion. So the amount of data that you will receive from the streaming is not predictable in some sense. And creating features for real time means you have to create all the features, process the data, ingest it on the fly, right? You cannot wait like 1 day. I cannot do it at night kind of thing. I have to do it right now and then. So yes, this is tools that we can use to create data pipeline. It's called Apache Beam. So Apache Beam is open source right now. It's a unified model for batch and streaming. What it means is I just have to write one code. It will work with both streaming and batch. You don't have to change anything in the logics and all that. You just have to change the source, right? So I'm reading from batch file. Now I'm reading it from the source or the streaming, right? And it's also used like multi-threadings and all this sort of sharding to help with large data processing. So you just have to put in more nodes to it, and it can sort of scale up, right? To process. If there's like demands high, you just increase more server to it. It should work as is, it doesn't limit the ability to scale up. If you want to take a look at it, you can just Google Apache Beans, and it's open source, so you can take a look at it. And this is something that, how does this look like for Bean? Right? If you're a Python developer, you might notice some of the syntax is slightly weird because we are using things like pipe in this because we are pipeline. I don't know whether you get the jokes or not, but we are building pipelines, so that's why you use the pipe. So in this code, I'm creating data using a tuple, right? The data being the Apache Beam can accept emojis, can accept all forms of data, right? And I'm trying to group by using the key. The key is the emoji, right? And I try to join the words that I have, so which is like Google Cloud is awesome. Then I print it out. So the output will be just one line, Google Cloud is awesome, with the emoji at the end. Right, so this is how Bings work. And if you can understand this, you're basically at 20% already into the understanding of the whole Bing, right? But it's a long, long climb to understand everything. So Beans came out with this, or rather like people came out with this. If the streaming data has no starts end, right? How about we process by time block, right? So we just split into like, in this case, it's 2 hours block. So every 2 hours, I will just use that 2 hours data to process it. Then I will output it, right? So these are my statistics for that 2 hours. So the next 2 hours, I will do the same. So it's like by time block process, right? And then there are 3 ways that you can process it. So I'm not sure anyone's familiar with windowing in data. Anyone? So it's basically try to move, right? So you are looking at 2 hours window, right? Every 2 hours, you process something. So this is like a fixed window. So this is 10 minutes. Every 10 minutes, I will process my data in some way. Then I will put the result back. So the use case will be to like calculate the number of transaction happens within that time frame, and also how much transaction has been happened within that time frame. So it's like every time frame you have some output. But sometimes you don't want that to do, right? So sometimes you want it to be like a moving average. So you don't want it to like every 10 minutes kind of thing. I want what's the average last 10 minutes, right? What's the average last 20 minutes? I don't want it for this like 9 to 10 kind of thing. Every minute I want it like 1 hour back. So in that way, you can sort of use this sliding window. So sliding window have some overlap because it's always go back to like and check, right, within like from this time, what's my average within like 1 hour from the time that I'm executing it. So this is like sliding window. And the use case is like moving average, right? The transition of it. And another one is called session window. The session window is more applicable for things like tracking the user behavior. So when you log into a website, they can start the session. And then when you logged out, they will close the session, right? Because you won't be logging back in until sometimes, right? You won't be like log out, log in, log out, log in all the way, right? So this is the sessions that you can use to determine, let's say, each person within the sessions, how many clicks they do, right? How many buttons they click, how many products they browse, how many they put into the shop to cart or things like that. So this is how they use for streaming. And the determining factor for this is by the gap rather than the time block. So if there's a gap of more than 5 minutes, they will take it as the next session. So the 5 minutes is arbitrary, so you can define it to be like 1 hour, right? So if the user has stopped for 1 hour, you will take it as a different session when it's come back again. Yeah. So this is like arbitrary number that you set, right, based on your business case or your domain knowledge. So, and my task can't fit into any of these three, because what I need is every records, I want to go back in time and check what's last 15 minutes, what's 20 minutes, what's 30 minutes and 60 minutes. So I need to put in a little bit modification to the sliding window function. So I use the offset, right? I have to start from the start, right? So, but I don't know when's my start. So I have to put offset to it. So I only want to take this, in this case is 1 minute buffer. So every 1 minute, I will process the last 15, 30, and 60 minutes data. And it will keep on stacking so that I don't have any unprocessed data, if that makes sense. So every time I execute, my new data will be just 1 minute interval. Then I will calculate back, 60 minutes, 30 minutes, and 15 minutes. So this is the approach that I took, and it took me a while to get it right. So yeah, here I am talking about it. And the difficulty with streaming data still exists, even though I'm using Apache Beam, right? It sort of solved this no beginning and ends because I have this offset function to always go back, right? Whichever data has the start date, I want it to be offset by 1 minute. So I will always start from the start of my data streaming in, right? And it never ends because it will always stack, right? So it sort of solved that. If some records will be arrived late, Apache Beam handle it by having this kind of thing. The logic says like watermarks. So they have like this opening window after this window. So there's a lot of window going on. If the data is arrived at that allowed time, they will just take it as part of this. If not, they will just take it as a next window, something like that. But this is running on like local settings, right? Because it's open source, I have to get my own server and everything. So I can't solve this unpredictable amount of data. And I can't solve it in real time because I have to keep running my code to process it, right? It has to be done in a managed way. So if I just have something that can automatically scale based on my demand, right? Like if I want 3 GPU today, then tomorrow maybe I want 6, but the next day I want 1. Should be able to scale up and down, and it should be running 24/7, right? So it has to be something, I have to use server or something, right? So this is some of the offering, like one of the offering from Google Cloud. It's called Dataflow. So Dataflow is actually Apache Beam, but managed by Google Cloud. So they just name it differently. So everything is handled, right? You have a fully managed data processing service. You have automatic provisioning, managing of resources. You can do horizontal scaling. You can have like a reliability of 99% right? And it's tied to the Apache Beam's open source because it's like the Apache Beam's managed, right? So whichever the Apache Beam has, it will work on Dataflow. And it's actually, if you look at the history, is Dataflow started first, and then they donated the package to Apache Foundation, so it became open source. So it's the other way around. But yeah, so once I use that, I have solved all 4 difficulties that I had previously. So now I can scale. Now I can just run the job, and then it will handle everything. So I don't have to wait for it, right? I don't have to run my laptop again and again. So now I will quickly go to live demo. I think I'll still have time. So the code will be slightly long, but I will explain you throughout. So the code is open source actually. So you can just go to you can take a picture, I think. Yeah, or you can scan it. You will reach to the GitHub page, and then you can run the notebook anywhere. So I will give 30 seconds. Is GDG SG bin August 31st. So you should be able to get that. Okay, just one. Okay, so I just opened this up. So this will bring me to my GitHub, but I have added in these functions. So you don't have to clone it. You can just click run in Colab. I need to control this. Okay. So I have saved you some time in downloading it, putting it to Colab and everything. So it would straight away run from Colab here, right? So first thing first, I made sure that the width is high. I mean the width is wide so that you can see everything. Now it's just provisioning the VM for us to run stuff. So before I go, I would just say this is we will use Apache Bean first, the way I sort of learn it from. You use Apache Bean with a batch of data. Then we will change it to use the streaming data with the same code, same infrastructure. We just change the source. So once we change the source, we have built a streaming pipeline properly, right? So once we have that pipeline already, we can just deploy it to Dataflow, and it's done in in the Jeffrey. So I will run through that notebook again. Send the features we are doing: customer spending features and terminal transaction features. But I leave terminal transaction features for you guys to do as a homework when you go home. You can try this. And yeah, so usually in machine learning setting, you would try to do EDA, exploratory data analytics, before you try to do feature engineering. But in this case, I'm just covering the feature engineering aspect, so I will be covering that in my notebook. For the data set, we are trying to use this practical handbook project from the Kyaw to synthesize the data. So the data is actually not real, in case you're wondering. So the objective of this is to learn how to use Apache Beans to create the pipeline, and then you apply this windowing and the aggregation functions to create the features, and then deploy it to Dataflow. Right, it's 3 things, simple enough. So first thing first, I got to install this Bean. Just install Apache Bean using pip. Just wait for it, and then once it's installed, we just have to restart the runtime, and then we're good to go. You only have to do this once if you're running it from a local, but if you're doing it from Colab, you got to do it every time, because Bean is not part of the Colab offerings, and you got to do it. So it's building it. So wait for a while. Is everyone okay? Anyone's lost in the until here? Okay. Can I get a hoo-ha? No, just kidding. Right, so I just installed it. It doesn't matter because I'm not using TensorFlow at the moment. Right, I'm going to restart this. So my session crashed and it's already restarting. Then now I'm ready. So I will just import all the library. Right, is the standard one: JSON, time, Apache Bean, pipeline options, and combiners. So if you're from Spark background, you'll be familiar with things like combiners, like Hadoop, Spark kind of thing. Anyway, so we are trying to do 15 minutes, 30 minutes, and 60 minutes window, right? So I will define these minute windows. And then because a lot of things work with seconds, so I will convert them into seconds by multiplying with 60, right? For the window size, like how wide I want to cover is the maximum size, so the largest window. And then I will have a 1 minute interval, right? The period of 1 minute, I want to process that. So I run this, still have some time. So, right. So these are the auxiliary functions that I pre-written. So by right, you will be exploring and then you will write the functions, right? So, but in this case, I will pre-write it. So one of the functions is just try to convert the time into Unix, right? The other is to print the element. So in beans, you cannot just do like print something because everything is distributed, right? You cannot just print it. You have to like make sure you're passing it to a do function and things like that. And the other is to add additional info. So in order to calculate the last 15 minutes, I need to know the last, the Windows end time. So window end time minus like 15 minutes, that will be my start and end date, right? So in order to do that, I got to add it in because my data doesn't include that. So I got to calculate it myself using this window end function, and then I will calculate the time difference. So while I'm calculating time difference in this case is to determine whether they are last 15, 30, or 60 minutes. And then I'm trying to reformat it. So by the time I went through the notebook, you will understand why all these functions are helpful, right? So first thing first, we work with batch data. So batch data, I will just create a dummy data in this case, right? And I have 10 transitions that I sort of, put as a dummy. So you can define it in like a list or tuple. So it doesn't matter what you have, as long as it's iterable, it should be okay. So I'm defining this dummy data. And then once the data is here, I need to build some pipeline that can read in that data, right? So the start of the start. First things first, I need to define the pipeline options. So I'm just doing due diligence of checking all the type, right? Saving the main section so that the other parallel processes can come back and like read the things. And for the runner type, I'm doing direct runner. So direct runner means you're running locally. So they call it direct runner. So if I run this, I should be able to see, bring it for, so I should run this, then I should run this. So it should be reflecting whatever I put in as a dummy data, and it should go inside the pipeline, right, that I print it up. So I'm just printing out whatever I put in from the top, printing it back. I've done nothing to the pipeline yet. So now we can read the data. We should enrich it by adding attaching the timestamps, creating a window by slicing the data and converting into like name tuple so that easier to work with, and then adding the window info, the function that I defined previously. So you can just do by all these things like map and like padu, right, and the window into functions. You can read about them like later. So once I've done this, I'm actually transforming the input data. So if you compare with the first one doesn't do any transformation. But once I've done the transformation, you will see things has changed, right? I have converted them to row, and then I have added in some other information like the composite key, right? All this information that I need to aggregate the data. So once I have the composite key, I will just add in this aggregation function. So aggregation function is done by things like group by. So if you are from like SQL background, you should be familiar with this. So it's like group by, and then I define how to aggregate things. So for example, the first one, I will check whether the time difference is like the 15 minutes seconds. Yeah, 15 minutes times 60 seconds. If it is, I will just take it, right? So it's like I'm going through every rows within that time frame and check whether my criteria is matched. So if it is matched, right, I would just take it as 15 minutes transition. Same thing for like 30 minutes, right, which is this one, and the 60 minutes. So 60 minutes, I don't have to check because everything is within that 60 minutes because I'm splitting into like 1 hour block. So that's that. If I run this, I should be seeing different results, right? So I have set composite key as the key, and then the results are all the things like the number of transaction within 15 minutes, number of amount, start amount 15 minutes, and average is 50 minutes, things like that. So when I have this aggregated data, right, I remember I have 1 minute's data that every interval I'm taking in as a fresh data. So I just join that two back, right? So I will get the new slice of data, which is this. From the enriched source, I'm just filtering whichever has the less than or equal to 1 minute interval, right? I will just assign the same key, which is the composite key. So once I have the same key, I can merge them back. So I will just merge collection in this way using the co-group by key. And then I filter whichever doesn't have anything. So this is practically doing the left join, right? But in a hard way. So after that, I will reformat it using the function that I defined previously. Then I will print it out, right? So after I have done everything, this is the results. I have put in 10 records. It came back 10 records, but with all the other additional information, like number of transaction, 50 minutes, number of transaction, amount, average amount, all this information, right? So this is like SQL kind of thing, but you are writing it in like a bean. So this sort of conclude that the pipeline is working fine for batch data, right? So to be able to run it on a streaming source, you have to use a streaming source like Kafka or PubSub or some other offers, like some other solution that is able to stream data. You can also have your own Python script pumping data to here. But in my case, I just create some cloud project, right? So if you follow this step 1 to 5, you should be able to get a key, which in my case is this. So I will just copy my key over. If you've done this, then you will have a key that you just upload to whichever one that you're running to, right? So I need to set this key into my path, right? Just set this. Okay, then I need to change my project ID. So how do you get project ID? You can go back to the Google Cloud project, or you can just read it from here. So there's a project ID that I can copy. So this is my project ID. And the rest is we already set up for you. So this PubSub topic is actually public. We just made, make available for everyone to try. So you can just create this subscription, and then you should be able to see the synthesized financial data that we are going to release. So I'm just defining the cloud variables so that I have a project ID. I know which region I'm running to, right? I have which subscription I'm actually consuming the data from. So once I have this, I have written this code to just pull like 5 records from the streaming site. So if you want to understand, you can quickly read it. But if I run this, it should bring out the 5 records. Okay, so exactly very similar to the dummy data that I just created, but these are real data. So you have like transaction ID, timestamps, customer ID, terminal ID, then amount. And they also have this, whether it's a fraud or not, so that you can use as a label to train machine learning model later on. So now we have done this. We know is that our Google Cloud connection has worked because we just retrieve some data from the cloud. Then we can start running it, right? So we just have to change something. In this case, I just have to change the source. So this source, I'm reading it from the PubSub. And when you read it from the PubSub, it came in binary. So I need to convert them into array. And that's it. The rest of the code are actually the same as the previous, right? I'm just enriching the source, aggregating the customer ID, getting the new records, and then merge them. So if I run this, it should print out something similar to what I have done initially, which is this one. So, but this is, if you notice, is running all the time because it's streaming data, right? So the data is always coming in, you're always running. But if I have to close my laptop, I have to stop, right? Because I cannot keep on running. So I got to just click it and it should stop. But now I need to find a way to make it work permanently, keep it running even if I'm not using my laptop. So if you notice, the only one things that you need to change to, two things that you need to change to your pipeline to be able to work with streaming data is by adding this streaming go to true, this one, and you just change the source. That's it. Then your batch pipeline now works for streaming. How cool is that, right? You don't have to rewrite the whole thing, right? So, and now I'm going to show you the magic. How do you deploy this to Dataflow? Is just by changing the runner. So instead of direct runner, we are changing to Dataflow runner, and then we add in our project ID, the regions, and the temporary location that we want to store our output to. And that's it. So if I run this one, it shouldn't print out anything because it's going to be running on here. So if we wait for a while, it will appear as running. So these are some of the trial run that I did in the morning. I have already canceled those runs. So if you notice, it's running, but it's not actually running from the terminal that I'm running. It's running to the cloud. So it's going to appear here. Yeah, we just had it. So it's running. And if you go inside, you can see the diagram. So this is like all the steps that I defined just now with the code, right? Reading it from PubSub, right? You converting it to data, JSON digs, and then adding to the timestamps, creating window, adding window info, converting to name tuple, right? Then the group by, filtering, and also the assign element, merging it back. So you can see every steps that happens on the console itself. Then you can know, right, which one has error. If there's error, they will turn it red. Then you can go and take a look at what happened. And it's keep on running. So now it's running, and it's running for 35 seconds. So we can just leave it open. So then that's it. So you don't have to change a lot of settings. So it's make deployment so much easier, right? If you ever in deployment situation, you have to change a lot of things to make it work for like production versus your dev. But in this case, you just have to change some settings or the options, and it works. Now we are back to, I will just let it running to show you what's going on. So anyone still wants these demo slides? If not, I will move on. Right, I only have like 10 more minutes left. So yeah, so what's next from here, right? Like you just learn Apache Beam, sort of. So I want you to try this notebook out yourself, right? And see which part you don't understand. Then you can deep dive into that part by going to documentation, asking people, or you can just contact me, right? I will try my best to answer. And you can implement, so I haven't implemented this terminal transaction features. It's very similar to what I've done. You can do this again, just by changing some parameters. So you can try do that. And then if you are, want to challenge yourself, you can create more features from that, right? Be it last one day, I don't know, you can do that. And try to run this job on Dataflow, right? I know running Dataflow requires you to have the credits, right? I will give you later, right? So come and find me if you want credits. I can give you some. It's not much, but I will give you some. Then yeah, if you ever manage to run it, right, screenshot the diagram, share it, and then tag me, right? I will try to see whether you're doing a good job, right? You might win some swag, who knows? So yeah, try it out. And yeah, so if you are coming in to get a free credits, this is what you need to know, because you have to go to this link and then put in the coupon code. I will only give you the coupon code. So you should take like screenshot of this and then come and find me afterwards. I only have very limited amount of coupon. Where, they are here. I will get some stickers also. So yeah, find me later. Oh, good. Everyone got it. It just cloud console cloud Google then /try GCP. Right. So once you put in this coupon code, you won't need to key in your credit card information anymore. You will be able to access whatever things that I just run through, right? And you will have some credits that I gave you, right? So there's no downside of not trying because you won't have to pay anything. And you have to redeem it by like tomorrow because I don't want this to like spread. So I will just limit it by tomorrow and it will last for like 1 month to 2 months. Yeah, so you can try every other things. Don't have to fix the data flow thing. So you have like some money to spend. Okay, so one thing I want to share is we are starting this thing called Cloud Innovator Program. Right, so Innovators is free to sign up. There's no bar requirement. You don't have to be technical and all this. What we do, like what you get out from this is sometimes we organize exclusive events for the innovators. So we are going to organize one big workshops for innovators only. So it go by invites kind of thing. And they do like seminars and all this exclusively for the innovators. So if you haven't on this program, you can just sign up. It's free and we don't ask anything, no credit cards information. It just, I want to be innovator. Then you just click OK, then you become innovator. Oh, good. Okay, so yeah, that's pretty much it. Thanks so much for your attention, and I hope you learned something. And yeah, if you want to tag me on social media, these are mine. You can scan this QR code to go to my LinkedIn. You can email me. You can tweet me from Twitter. Yeah, this is me. And thanks so much for your attention, and I hope you have a good one. And find me for the coupon code, okay? Right, yeah, thank you.